Hello and welcome to this AQA Further Maths Statistics video, the first in a series looking at discrete random variables. So first of all, let's think about the term random variable. There are two words involved here. The first one, variable, indicates that its value can vary. And the second word, random, those variations in its value are due to chance. And if we put those two together, random variable would describe the sort of event that we get when we roll a die and look at the score that we've obtained. We have a variety of outcomes and those values vary. So with a normal six-sided die, the score has a value that can vary 1, 2, 3, 4, 5 or 6, and the variations in the score that we obtain on the roll of a die are due to chance. And do notice that the score is indicated with a capital letter X, and that's our random variable. And if we summarize in this table the outcomes that are possible, so we could have a score of 1, 2, 3, 4, 5 or 6, and on the second row we identify the probability of each of those possible outcomes. We then have two different ways of writing X. Say the capital X denotes the random variable, which is the score on the die, and the lowercase x indicates the individual outcomes that are possible. So if we look at the possible outcomes for the score on an unbiased hexahedral or six-sided die, this was the table we had before, and sometimes discrete random variables can be described not in a table, but can be written in a different form. So this discrete random variable, that is actually a discrete uniform random variable, can be described with this probability distribution, because for values of x between 1 and 6, the probability is 1 over 6, and the probability of obtaining any other outcome is 0. And so you may find discrete probability distributions either described in a table or in this more formal way as down here. So just to remind ourselves of the properties of a discrete random variable, we must have the probability for any outcome that is possible greater than or equal to 0. So every probability will be greater than or equal to 0. And secondly, the sum of all the probabilities covering all the possible outcomes must equal 1. If we look at a fairly simple example here, you can see that this is written in the more formal way. It doesn't actually include the 0 otherwise, but you will often find that written in. But we are told this time that the probability that x takes any value 1, 2, 3 or 4 is k multiplied by 2 to the power x. So notice it's the power of x that is changing dependent on the outcome we're interested in. And the first thing we've got to do here is to find the value of k. And in order to do that, we need to use the fact that the sum of the probabilities of all the possible outcomes must equal 1. So if we write down on our line, top line here, all the possible outcomes, 1, 2, 3 and 4, and then underneath we write down the probability of getting each individual outcome. The probability of getting 1 would be k multiplied by 2 to the power 1, so that's 2k. The probability of getting 2 would be k multiplied by 2 squared, so that would give me 4k. The probability of getting 3 would be k multiplied by 2 cubed, so that's 8k. And the probability of getting 4 would be k multiplied by 2 to the power 4, which is 16k. And here we have our probability table for this random variable x. So if we now look at the fact that we know the sum of all the probabilities must equal 1, it's fairly easy to just write down an expression for the sum of all the probabilities, or you might be able to do that in your head. That must equal 1, and that will give us 30k equals 1, k equals 1 over 30. So the second question was to find the probability x is greater than or equal to 3. So we are interested in these two probabilities here, greater than or equal to 3, so 3 or 4. So the probability of x being greater than or equal to 3 is going to be 8k plus 16k. That gives us 24. K was 1 over 30, so 24 over 30. And that concludes this first video.